Welcome to Thermodynamics lecture series. In the present video, we will discuss the numerical problems of first law of thermodynamics. Let's see the problem. A fluid system contained in a piston and cylinder machine passes through a complete cycle of 4 processes. The sum of all heat transferred during a cycle is minus 340 kilojoules. The system completes 200 cycles per minute. Complete the following table showing the method for each item and to compute the net rate of work output in kilowatt. So here given the sum of all heat transfer during a cycle. So let's consider summation of Q cycle equal to the minus 340 kilojoules, and also given that the system completes 200 cycles per minute. So then you have to determine the net rate of work output in kilowatts. So have to determine. Okay. So we will go for the process 1 to 2. In the process 1 to 2, so heat transfer given and the work transfer also given. So del E is not given. So based on the first law of thermodynamics, Q equal to the del E plus W. So Q122 equal to the 0 and W122 equal to the 4340. Then this equation will become the 0 equal to the del E plus 4340. Then del E equal to the minus 4340 kilojoule per minute. So next we have to look for the process 2 to 3. So in the process 2 to 3, it is given the Q2 to 3 is given 42,000 and W2 to 3 is the 0. Then del E equal to the 42,000 kilojoule per minute. Similarly, for the process 3 to 4, so here Q is given, Q3 to 4 is given minus 4200 and W is not given, and del E equal to the minus 73,200. So then W equal to the 73,200 minus 4,200. So then it is the W3 to 4 equal to the 69,000 kilojoule per minute. So next we have to go for the process 4 to 1. So in the process 4 to 1, so Q4 to 1 is not given, W4 to 1 also not given, and del E also not given. So in this regard, but in the data it is given the Q cycle is given. So Q cycle equal to the minus 340 kilojoules. So Q cycle is nothing but so Q122 plus Q223 plus Q324 plus Q421, which is equal to the minus 340 kilojoules, but system completes the 200 cycles per minute. Then minus 340 into 200. In this one we know the Q122 is the 0, Q223 is the 42,000 and Q324 is the minus 4,200. So then substitute this all values, we will get the Q421 is the minus 105,800 kilojoule per minute. So we got the and we know that cyclic internal energy of any property is 0. Then delta E122 plus delta E223 plus delta E324 plus delta E421 equal to the 0. So here we got the delta 122 and 223, we got the values, and delta E324 is given. Then delta 421 will become the minus 4,340 plus 42,000 minus 73,200 plus delta E421 equal to the 0. Then delta E421 equal to the 35,540 kilojoule per minute. So in the process 421, so we got the Q421 and delta 421. So we got the Q421 and the delta E421. Then W421 equal to the Q421 minus del E421. So we know the values, then substitute. So we will get the net work rate in the process 4 to 1, that is W4 to 1 equal to the minus 141,340 kilojoule per minute. So this is the solution. Let's see the another problem. 0.2 meter cube of air at 4 bar and 130 degrees Celsius is contained in a system. A reversible adiabatic expansion takes place till the pressure falls to 1.02 bar. The gas is then heated at constant pressure till the enthalpy increases by 72.5 kilojoule. Calculate the work done and the index of expansion if the above processes are replaced by a single reversible polytropic process giving the same work between the same initial and final states, and consider the Cp value equal to the 1 kilojoule per kg Kelvin and Cv equal to the 0.714 kilojoule per kg Kelvin. So we have to write down the given data. So it is given the 0.2 meter cube of air. So initial volume V1 let consider, which is equal to the 0.2 meter cube, and initial pressure P1 equal to the 4 bar, which is equal to the 4 into 10 to the power 5 Newton per meter square, and initial temperature let consider T1 equal to the 130 degrees Celsius, which is nothing but 130 plus 273, which is equal to the 403 kelvins, and it is the initially it is the reversible adiabatic expansion. So in the expansion, obviously pressure it will be reduced. Then P2 final pressure, it is given the 1.02 bar. So final pressure after the adiabatic expansion, let consider P2 equal to the 1.02 bar, which is equal to the 1.02 into 10 to the power 5 Newton per meter square. And also given the heat is added, so heated at a constant pressure till the enthalpy increases by 72.5 kilojoule. So it is given the increase in enthalpy. So in the constant pressure process, during constant pressure process, which is equal to the 72.5 kilojoule. So this problem had to represent this schematically. So process 1 to 2, it is the adiabatic expansion. So here it is given the V1 value and P1 value, P2 value also given. So T1 value is given. So process is the adiabatic expansion, and process 2 to 3, P2 equal to the P3. So final pressure also given, P2 equal to P3 we also given, and also given that so rate increase in enthalpy is given, that is the 72.5 kilojoule. So then we have to determine the net work done, and also have to determine the index of expansion if we are considering the polytropic process, same work done. Okay, so and also have to consider the Cp values are the 1 kilojoule per kg Kelvin and Cv equal to the 0.714, so kilojoule per kg Kelvin. Okay, let's see the solution. First we have to calculate the work done. So observe the process 1 to 2, which is the reversible adiabatic process. So in the data it is given the initial pressure and final pressure P1 P2 given, and V1 also given, but we don't know the V2 value. So to determine the work done we required the V2 value. So for this one we have to determine first V2 value, and we know the relation between the P and V in the reversible adiabatic, that is the P1 V1 gamma equal to the P2 V2 gamma. But gamma value is not given in data, but it is given the Cp and Cv value. So gamma equal to the Cp by Cv, which is equal to the 1 divided by 0.714, which is equal to the 1.4. So gamma equal to the 1.4. And V2 equal to the V1 into P1 by P2 whole to the power 1 divided by gamma. We know the V1 value, P1 value, and P2 and gamma value. Substitute all these values in the V2 equation. We will get the V2 equal to the 0.53 meter cube. So next we determine the temperature, also final temperature in the process 122. Initial temperature is given the 403 Kelvin. So okay, we know the relationship between the temperature and pressure, that is the T2 by T1 equal to the P2 by P1 whole to the power gamma minus 1 divided by gamma. So here substitute all these values, we will get the T2 equal to the 272.7 Kelvin. So in the process 122, we know the initial values of the pressure, volume and the temperature, and moreover we know the final pressure, volume and the temperature. So okay. So next we will determine the work done in the process of 122, that is a W122. We know, so in the reversible adiabatic process, work done equal to the P1 V1 minus P2 V2 divided by gamma minus 1. So here we know all the values, then substitute, we will get the work done in the process 122. So W122 equal to the 0.6485 into 10 to the power of 5. So we determine the work done in the process 122. So okay, next we have to look for the process 223, which is the constant pressure process. And we know in the constant pressure process, heat transfer equal to the, so change in enthalpy, that is the mcp delta T, which is equal to the mcp T3 minus T2. Similarly, work done in the constant pressure process. So process 223 is the constant pressure process. So W223 equal to the P2 into V3 minus V2. So for the work done, we know the P2 value and V2 value, but we don't know the V3 value. So I have to determine the V3 value. So we know relation is, so P1 V1 equal to the MR T1. So here P1 we know, V1 we know, and M we don't know, and R value also we don't know, T1 we know. But R is the relation we know, R equal to the Cp minus Cv. Then R equal to the 1 minus 0.713, which is equal to the 0.286 kilojoule per kg Kelvin. Then substitute all these values, we will get the M value. So that is the M equal to the 0.694 kgs. So we have to observe the net heat transfer, which is equal to the increase in enthalpy, that is given in the data, which is the 72.5 kilojoules. So 72.5 kilojoules equal to the M value we know, 0.694 kgs, and Cp value also we know. So but T3 we don't know. So T3 value we don't know, and T2 value we know. So from this relation we can be find out the T2 value. So here, so H3 minus HD, that is the increase in enthalpy. So 72.5 kilojoules, 72.5 into 10 cube equal to the M value 0.694, Cp value 1 kilojoule per kg Kelvin, which is equal to the 1 into 10 cube, and T3 minus T2 value we know, that is the 272.7. So from this relation, so final temperature in the process 223, that is the T3 equal to the 377.2 Kelvin. So now we know the final temperature also we know. So next we determine the V3 value. So we know in the constant pressure process relation is, so process 223 is the constant pressure process, then V2 by T2 equal to the V3 by T3. Here we know V2 value, T2 value and T3 value. Substitute all these values, we will get the V3 equal to the 0.733 meter cube. So to determination of the work done in the process 223, we know P2 value, V3 value and V2 value. Then substitute all these values. Then work done in the process 223 equal to the P2, that is 1.02 into 10 to the power 5, and V3 0.733 minus V2 0.53. Then work done equal to the, so 20,706 joules. So then So net work done. So for the entire the process 1 to 2 and 2 to 3. So work done of the process 1 to 3, which is equal to the work done in the process 1 to 2 plus work done in the process 2 to 3. So we know the values. Then so work done, net work done equal to the 85,556. Next we calculate the second question. The index of expansion if the above process are replaced by a single reversible polytropic process giving the same work between the initial and final status. So let's consider the process is polytropic process and work done is the same amount of the work done in the reversible adiabatic expansion. So then, so W123 we know and work done in the polytropic process we know. So P1 V1 minus P3 V3 divided by n minus 1. We have to determine the n value. So here W123 equal to the 85,556 and we know P1 value, V1 value, P3 value, V3 value. All the substitute. So this relation will become the 85,556 equal to the 5,234 divided by n minus 1. So this from this equation n minus 1 equal to the 0.062, then n equal to the 1.062. So this is the solution and thank you.